In this mini tutorial, we're going to find out more about working with oxidation numbers, and particularly how we can use oxidation numbers to determine whether a species is being oxidized or reduced during the course of a redox reaction. So let's think about the reaction shown here, which is also included in chapter 12 in the book, which is showing methane reacting with chlorine to give tetrachloromethane and hydrogen chloride. And the question we want to ask is carbon being oxidized or reduced during the course of the reaction? If we look at this reaction as written, there's really no way of knowing. So instead we take the following steps. First, let's just draw out the structure of the carbon containing compounds before and after the reaction. So you've got methane that has carbon joined to 4 hydrogen atoms. And then in the product, the carbon's now joined to 4 chlorines in place of the hydrogen. And to work out whether the carbon is being oxidized or reduced, we need to work out its oxidation number before and after reaction and compare the two. We do this in 2 stages. First of all, we consider the reactant, so the methane. And first of all, we imagine that the carbon and the valence electrons rather joining the carbons and the hydrogens are equally shared. So in each of these covalent bonds there are 2 valence electrons. And first of all, we imagine that the electrons are equally shared between the carbons and the hydrogens, which would look something like this. So I'm going to change colour to show the electrons here. So there'll be 1 electron in each bond is associated with the carbon and 1 associated with the hydrogen. We then imagine that these electrons are distributed ionically. If you remember from chapter 3, ionic bonds, the electrons are transferred entirely to the most electronegative element. In this case, carbon is more electronegative than hydrogen. So if we were to distribute the valence electrons ionically, they would all associate with the carbon and not with the hydrogen. So we then ask what the difference is between the distribution of the electrons under the equal share model, the one shown here on the left, versus the ionic model. And if we look here, the carbon has 4 valence electrons under the equal shared model and 8 under the ionic model. And to get the oxidation number, we say the number of electrons shared minus the number in the ionic model, which in this case is 4 minus 8, which gives us minus 4. We then need to think about the equivalent situation in the product. So this is now with the carbon and 4 chlorines surrounding it, like this. And I'm just going to write it out twice so that we can do the same equal and ionic distributions that we did for the methane a moment ago. So again, I'm just going to switch colours. So under the equal model, again, the electrons are shared in the same way as in methane. Still the same number of valence electrons in each bond, and they're shared equally like that. Under the ionic model now, remember, we're distributing to the most electronegative element, and carbon is a lot more electronegative, chlorine rather, is a lot more electronegative than carbon. So now the valence electrons are all being associated with the chlorines and not with the carbon, like so. And this time, when we look at the distribution of electrons, okay, we've got 4 there around the carbon, but on the right hand side in the product here with the ionic distribution, there are none. This time the oxidation number is shared minus ionic, which is +4. So we see that the oxidation number of carbon has gone from -4 in the reactant to +4 in the product, the tetrachloromethane. So from that, has carbon been oxidized or reduced? Well, we say that if the oxidation number has increased, the species has been oxidized, and if the oxidation number has decreased, the species has been reduced. In this case, we can see there's been an increase from -4 to +4. So you can say that when methane has reacted with chlorine to form tetrachloromethane, the carbon has been oxidized.